Hello everyone, welcome back to OBINexus. My name is Namdi, but you can call me OBINexus Namdi. Today I want to update, tell you about a new. I won't say the framework. I will say it's more the library because I don't like frameworks in general. Because it's a UI UX library with framework-like features. Let's call it that. Uh, the library is called OBX or OBIX. It is a UI UX library written in TypeScript with Node.js and Rollup. OBIX is really or OBI meaning OBI meaning heart or soul in Igbo. My Igbo because I'm an Igbo man. The Heart UI UX library. Yes, that's what OBIX is. OBI means heart in Igbo or soul, or depending on the plane of existence you are from or in. um, the UI UX library. It's designed for fraud mitigation, where fear, uncertainty, and doubt are taken into account to give the best user experience. What that means is that OBIX mitigates fraud by providing accessibility support in such as components and all of the above. To mitigate a UI following the mobile first principle, where you design for mobile first and not the desktop, because the majority of the user base are always on mobile anyway, which is why the mobile first principle really shines. Now, how does OBIX mitigate fear, uncertainty, and doubt? At OBINexus, we see fear, uncertainty, and doubt as a barrier between us and our users. Anyone working on a project, the stakeholders, risk and reward, the barrier or the consumer and the customer, or between the consumer. The customer is one that buys the product, buys and sells and redistributes the product, maybe to a franchise some source. But OBIX, we are the stakeholder. I'm a stakeholder. So if I'm a stakeholder working on OBIX projects or OBIX components, which is like a lit component, which is really React friendly. It's a React complaint system. After mitigate forward, think about accessibility as a first principle, mobile first accessibility. So how does OBIX mitigate forward really? At the component layer, OBIX integrates WA, the Web or Standard Organization area attributes and enforces them through policies. These policies are really decorators or wrappers around functions that are invoked when a function calls. Think of it as a TypeScript add decorator that you can use a QA matrix, which is a true positive, true negative, false positive, false negative, to decorate a component, such as the React component. You have to know that OBIX is not a React component itself, but it's React compliant. It really understands the features of React in a way that is people can migrate from React into OBIX UI UX library. So that's how fraud is first mitigated. Now, the second way fraud is mitigated is through a telemetry system. You can track the state of components and see how something behaves in real time. Using the telemetry command, track states of a system, of the component's logic. Instead of exhaustively testing each component in a testing library such as Mocha or Chai or any or the standard OBI testing frameworks. You don't have to bottleneck. You can literally just track the state and toggle the state machine of that component's lifecycle, like the JavaScript being invoked at that time. Using that library, you can get a telemetry system, log that for you, and see what went wrong between two component policies, anything. Yes, so the Heart UI use library is going to be deployed on NPM, which under the monoglot and polyglot or the hybrid schema. You have to understand we have three schemas. Monoglot stands for the single user base, like just Node.js or Python or Lua, just one programming code base for one language. The hybrid one allows for both monoglot and polyglot layers of interaction. You can build an F55 bridge to a front function to some other lower levels. Python is a C version of Python, which is like a Python is it's not generic. It's just Python. So if you want to access some low local, you can use Python to speed up the process of Python, your Python utilities. That's the schema thing. So we have the harmonoglot, which are the polyglot, which is like a many languages talking together, like a polymorphical system, ecosystem. And then we got the hybrid model, where you can interchange components together. Okay. Now, before I continue, I have to state we have when you if you do if when the OBIX is released, system is released onto NPM, you have to it has something called semantic versioning X. Semantic versioning X extends semantic versioning layers. It's my version of semantic version, where we have hot swappable components and traceable layers of the system based on the schema definition. Like if I went to at npm.com/OBINexus and find my package, I have a schema code at OBINexus. I mean like a slash, and I install at OBINexus slash or like OBIX. The schema allows flexibility between so for example, if I have to download a package, I'll write it down here. I think I write it down here. So for example, if I download the package at OBIX, I have to choose the type I want. Slash OBIX dot I got three options. The monoglot. That means just Node.js from NPM registry. Dot hybrid just means hybrid systems. I can use monoglot and polyglot layers to build my own program. When I do npm install at OBINexus, which is my business name, slash OBIX. But the default is monoglot. So that's the monoglot registry. And the polyglot. So you got the monoglot hybrid, which is hybrid component system, where you can build your own and deploy components in your infrastructure, or build or you can use a polyglot. It means many languages. That's poly means many. Polymorphic means many different types of data information. Polyglot. So you got that layers. Right now OBIX is only scope to the only schema only supports right now is defaulted to it has to be defaulted to monoglot because it's very experimental. Monoglot just for Node.js compliance system. Because I'm still working on the hybrid architecture. How to allow other components like lit to interact with the OBIX for that structure. And the polyglot allows you to have a backend to separate a Chevron location from the OBIX to the UI UX backend to talk to many other diverse set of languages to offer microservices for your web infrastructure based on the OSI security model. You have to understand that OBIX is really a React component system. It looks like React, it feels like React, but it's not React. Again, I repeat that. It looks like React, it feels like React, but it's not React. There's a lot of how this works in layman's terms is how this works. How this works in layman's terms is really it just works this. So you React React standards defines the React component. If you don't know that, that's how standards work. A standard defines a set of features that can be configured through a client interface. Or a standard is a specification. Can specify a standard says provide the foundation of a system, like a component. Like React uses functional components and class object components. But React is bloated. It has a lot of problems in duality, which I'll come and address next video. But it's React compliant just means it feels like React. It is React. It's not React because it obeys React standards strictly to define what's a functional component, what's an object component. It looks like React. It feels like React. Like the IntelliSense feels like React. But on Visual Code, it's not React. It's not React because of how it works. It's not React because there's something different about OBIX, even the hybrid model. Now, let me continue. So when you store OBIX, you have to use the monoglot or the polyglot hybrid system to using semantic version X, which is an extended version of the major minor patch system. Where the major can be versioned to separate the components. say for example, you're installing an OBIX in a real system, and you have a mismatch between dependencies. Say you have experimental layer, experimental version, can give you experimental version for each tier. So you have experimental features. Let's call the features. So say stable has experimental, stable, and legacy. And you want to let's say stable defilement is called alpha. Now this alpha channel stays stable. Anything stable can be hot swap. So what hot swap is just a sub-X feature that allows you to replace a feature or a component or something you don't want, or downgrade, upgrade. Based on the class setup or the taxonomy layer. For example, if I'm in alpha, the alpha channel, and I install, I'm in production right now, right, and something breaks, I made a small change and my dependency did not resolve. This is something called a statement, expression, and intent layer. This is what OBIX really enforces. For example, the statement layer is it's a statement. All statements are really expressions in disguise. A statement is just a true or false, true or false. Is it true or false? Is it a 1 or 0? The computer just evaluates the logic to solve. It's like a Boolean formula. It evaluates the logic and solves that formula, and then gives you an output true or false. Now this is a Boolean. It's Boolean because depending on how the time complexity of that resolution. What is log n, n, 2n? The statement is resolved into a Boolean, true or false, yes or no, one or the other, nothing else. Okay, now the expression layer is it allows you to express intent, express this. So the expression layer takes the statement one step further. It returns an array, a structure of that data. If I say something is true, what is the outcome of that data structure? What am I actually getting back from the function that I impose or the logic I have driven? And that's how that works. And the intent layer is the configuration system that says what's my intent when something fails. So if you're an alpha channel, not the beta channel, because that's like development, and the beta and alpha channel is released into GitHub from github.com/OBINexus to the npm registry. So that's what that is. So the semantic function allows, like, if you remember the sheep of Theseus. What really allows the component system for OBIX? It allows you to swap out versions or updates based on a schema, a taxonomy, how much stable, each code name. So if I name a stable version, stable code monkey, stable Stegosaurus. Stegosaurus, stable Stegosaurus. That's a stable and then I have a new stable which is a long-term support system for the OBIX X schema, which is semantic version X at OBINexus /semantic version in X. I can swap. I can now migrate those features into another stable class. Maybe call a new code name like long extended S for something that maps to a new version, and that's how the evolution works in the system using the specification. Now it's all standards and specifications, but not all specifications are standards because a specification declares more features of evolution. How do you define a new foundation so we don't roll back changes? It allows the system to evolve. Hence evolution adaptation at OBINexus. You have to understand that this statement expression layer and intent configuration is really can be any web compliance system like XML, JSON, or packages JSON or YAML, YAML lock. Anything that can configure a system in real time and roll back the changes and map the statement expression layers to the intent to allow for templating or parsing for the OBIX system. So this is just a good thing to do because it allows you to separate what you want to do from what you want to achieve in a what you see is what you mean configuration system or ways away. Okay. There's two type of system we can make. We can make a what you see is what you mean configuration, or what you see is what you get. Because what you see is like if you have a UI, which is kind of ambiguity, because these are UI interface structures. What you see is what you mean. It's like what you type in, like HTML syntax. The meaning or description matches what you see, and what you see is what you get. is more of a web philosophy when you have a like something like a Web3 like something something like an RSS feed. You want to map some data to it. So what you see is what you get is really about WordPress. Making WordPress as a website, but you don't fully understand the online structure. What is this is a gap between the two systems because these are two different ways of addressing a UI UX problem. So we can use the conversation system to give intent to of that system using what you mean, what you mean, what you see is what you mean, or what you see what you get. Okay. Yes, about the React components. It looks like React. It feels like it, but it's not React. In the next video, I'll show you a proof of concept of something called the data-oriented adapter. The data-oriented adapter is really a key principle, a key prototype, a proof of concept that grounds the whole foundation of the OBIX system. But there's three main. There's a tennis tracker example about how the tennis tracker or the automated state memorization works, and we got some prototypes I can show you too, which I will show you in the next video. But OBIX or the heart. See this logo? It's going there. No, here. No, I'm putting it here, but I think it's here. It flipped. I don't know. It's here. Yes, it's here. This heart. This is it won't make this logo there. It's called heart. That's my heart. So the OBIX system allows you to be flexible in how you translate LTS or long-term support into stable branches, allowing for developers and alpha channels to be cohesively matched to each other over the time or span of development for new features, evolving the standard into a configuration system that can be formally described in a schema, such as an SQL SMS schema or JSON schema or whatever you're building schemas with nowadays. But this allows for human out of the loop systems, which is HOTO, to really like AI systems that didn't need to be operational and autonomous by themselves, to be able to understand, ultimately to be able to understand instead and describe what we want to the system, to avoid the downgrade system where we don't have some mismatch. So in the next video, we will look at something called the data-oriented adapter, which is like my invention of a separation of concern between data that translates functional code into object-oriented computation, which is one foundational minimal viable product and prototype for the OBIX UI UX library. We then look at the tennis tracker, which is a state machine minimization that works by minimizing states of a machine by removing redundant states entirely. Not tracking only what's needed to simplify program interaction, and also look at how the concept of halting, state halting, in a system, so example, say you have an app, and you cache some data, and you leave that app. It's like a big app. It's a big app. But it's a big bloated app. It starts up slow and everything. One way around this problem is to cache only what you need as well. Because when you do an LIU cache, you have to cache all the whole system and evict it when the user clears it. It's a passive caching strategy. But when you actively halt the state of a caching system, and then when the user say convey something and the user is not returning with that storage anymore, it caches that state of the information and then evicts it. Eviction, when the user wants to evict it, you can come back, but only caches what is needed based on the automated state memorization algorithm. So when the caching is done, and the user just closes the app for some reason, and wants to resume, the user can just click on the app and resume, because the LRU caching, the least renewal caching, cacher, or if you enforce a TTL type of cache or time to live caching strategy, really just lowers the state of the component based on the telemetry tracking system, or what's been already transferred, where the user's progress is at, basically. It allows for the user to maintain interaction with that system without starting over again and reconfiguring settings or going to the settings too much, because it remembers the state of that application before and after it was closed. You just have to have a checkpoint to know to dictate how the user will behave, and how it doesn't have to have a checkpoint, but depending on how the service, you can just save a checkpoint anyway for the user, or give them frequent saves. Give them option to save their progress. However in the settings, but that's how that works. So that's what it is. So we're mitigating forward. We are okay. Thank you. That's all from me today. In this video. My name is OBINexus Namdi, but you can call me OBINexus Namdi, Michael Apala. Thank you and goodbye. Check out the repository at github.com/OBINexus/OBIX, which is the OBIUX UI/UX library. I will demonstrate the proof prototype after I make this video in another video. Thank you.